Good morning, my students. We are going to study the states of matter or substance. All substance is made of a tiny particles composed of tiny particles called molecules. They are in constant motion and attracted to each other. That this molecule and this other molecule move, vibrate, attract to each other and vibrate around the position of rest. This motion, and this motion with this motion vibrate according to the intermolecular spaces between molecules. This means that they have kinetic energy and velocity. Why? Because they are moving. These molecules are separated by a small distance called intermolecular distances or intermolecular spaces. Intermolecular distances or intermolecular spaces. The properties of substance. Substance found in the form of solids or liquids or gases. Substance found in three forms: solids, liquids, or gases. The diagram of solids, these molecules close to each other, and there is a small intermolecular spaces which is called intermolecular spaces. These spaces is called intermolecular spaces. The space between molecules of solids is very small intermolecular distances. This is from the characteristics of solid. And solid atoms or molecules arranged in irregular crystalline shape, regular shape. While in case of liquid, there is a distance, more spaces between molecules, because the molecules can move, vibrate, and translation motion, move easily, while the molecules of solid vibrate around the position of rest. And the intermolecular distances between the molecules of solid is greater than the intermolecular distances between the molecules of solids. While in gas state, molecules move in different directions, and there is wide spaces between molecules. It moves in randomly motion. From this is the diagram. The general properties. Solid has definite shape and volume. The shape of the solid does not change, and its volume is constant, has a definite volume. While liquids has a definite volume, this volume can transfer from container to another container, but it does not change. But not definite shape. The liquid takes the shape of the container. If the container has spherical shape, liquid becomes spherical. If the container is conical, the shape of the liquid is conical. if it in the form of cylindrical shape, the liquid in the form of cylindrical shape. While in gas, no definite shape, no definite volume at first. No definite volume due to the wide spaces. So the gas can be compressed and the volume decreases and has no definite shape. Has no definite shape like liquids. Take the shape of the container. Gas fills completely the volume of the container. Arrangement of atoms. Ordering. Arrangement of atoms. Arrangement of atoms. Molecules in solids regularly arranged in crystalline lattice. In crystalline lattice. While in liquid state, molecules randomly arranged, no order. In case of gas state, molecules randomly arranged, no order. This is the similarity between liquid and gas state. Intermolecular distances. Molecules are closely packed, strongly attracted to each other, because there is a small intermolecular distances or spaces between molecules. While in liquid state, molecules are loosely packaged. Molecules are far apart in gas state. Intermolecular forces, strong forces holding molecules together in case of solid state. In liquid state, weaker than solids, but still holding molecules together. In gas state, very weak, because molecules are far apart. There is wide spaces between molecules of substance. Motion of particles. Molecules vibrate or oscillate about a fixed point is called point of disturbance or point of equilibrium. Molecules move randomly in liquid state. They move, meaning slide over each other. While in case of gas state, molecules move randomly. They collide with each other, with the wall of the container, producing pressure. The compressibility. Solid, incompressible, cannot be compressed it. Liquid, almost incompressible, but the liquid which contains bubbles of air can be compressed slowly. Why gas compressible? Gas compressible can be compressed, From this, we can, using kinetic theory of matter, to explain the physical phenomenon, to explain kinetic, to explain the physical phenomena, plural, phenomenon, single. Theory used to explain the following physical phenomena, like temperature of the substance. Temperature of the substance, there is a physics phenomenon This is measure the average kinetic molecules. The hotter object, more kinetic energy its molecules have, and faster they move. This means that by increasing the temperature, the kinetic energy of molecules increases and the velocity of molecules increases. What causes the pressure inside a gas container? What causes pressure inside a gas container? Gas molecules are moving. They collide with the wall of the container. They collide molecules together and collide with the wall of the container, internal wall of the container. The collision between molecules together does not produce pressure. The collision between the molecules and the wall of the container produces pressure. This exerts force on the wall, which produces pressure. This means that pressure is produced due to the collision between molecules and the internal wall of the container by force on unit area to produce pressure, but this collision or impact is normally on the internal wall of the container. We have an example. Would adding air example for gas, to a car tire effect the kinetic energy of air molecules inside the tire. Air molecules added would result in more collisions with the wall of the tire, increasing the pressure of air inside it, because the pressure directly proportional with the kinetic energy. When the temperature increases, the kinetic energy increases, the collisions increases, the pressure increases, and the speed of air molecules will stay unchanged, meaning that the kinetic energy remains constant at constant pressure, and the temperature of the air molecules does not change. If the temperature remains constant, kinetic energy remains constant. The speed of air molecules would stay unchanged, remains constant. For example, for molecules of motion of molecules is called Brownian motion. Brownian motion means that the molecule move in a straight line for short times in any direction. Why the molecule change its direction? It changes its direction due to the collision between molecules together, and this collision is called elastic collision. Brownian motion, this motion explained by Brownian, is the random motion of particles suspended in a fluid. What is the meaning of fluid? Fluid, liquid and gas together are called fluid. Fluid substance can flow and has no definite shape. Together, liquid and gas are called a fluid. For example, smoke, molecules of smoke from the burning of straw is trapped in a small glass container that has bright light shining through it. It could also to be done on the bowling green. Another example, bowling green suspended in water. Bowling green suspended in water. This means that Brownian motion is the random motion of particle suspended in a fluid. Fluid, liquid, or gas. The meaning of Brownian motion, random motion of particles suspended in a fluid. Fluid, liquid, or gas. Gas, like the smoke particles due to burning straw, is trapped in a small glass container. Another example in liquid, bowling green suspended in water. Bowling green suspended in water. What is seen? Smoke particles or bowling green, small particles, example for gas. Bowling green, example in motion, in liquid. Both of them is called fluid. And make motion is called random motion of particles suspended in gas or in liquid. Bowling green or small reflect the light falling on them. And they are seen as a bright speck moving randomly in zigzag line. This line is called zigzag line. Zigzag line. This line is called zigzag line. The motion can be observed in this device. What is seen? This is microscope. This is a lamp. Lamp, source of light. This is a glass or cell, air molecules, and smoke particles inside it. By using microscope, we can observe the smoke particles move in straight lines for short time in a straight line. It changes its direction due to collision between gas molecules in elastic collision. Random movement, zigzag path of smoke particles, zigzag path of smoke particles. What is seen? Smoke particles or bowling green reflect light falling on it as a bright speck moving randomly zigzag line collection. Explanation of Brownian motion. The much smaller and faster air or water, because both of them is called fluid, molecules, move randomly in all directions, colliding with the large smoke particles or bowling green, causing them to move randomly in zigzag line direction. If air and water are warmed up, there will be more collision when the temperature increases because it warmed up. Collisions increases and the change in the direction. This means that the effect of it, when the temperature increases, the kinetic energy increases. Now, we study the relation between pressure, volume, and temperature. Pressure, volume, and temperature of a gas at constant mass. From the properties of substance, number 1, pressure. Number 2, volume, Number 3, temperature. Number 3, temperature. These are the 3 parameters affecting on it. We can study the relation between the pressure and volume at constant temperature, or the pressure and temperature at constant volume, or the temperature and volume at constant pressure. Again, we study the relation between pressure and volume at constant temperature, pressure and temperature at constant volume, volume and temperature at constant pressure. At first, we study the relation between pressure and the temperature, pressure and temperature. The change of gas pressure with the temperature at constant volume, this is the first state. When gas is heated, what happens? Molecules move faster, gains kinetic energy, colliding more often with the wall of the container. This means that exerts greater force on the wall and the pressure increases. Again, what happens? Due to the change of gas pressure with the temperature, what happens due to the increase in the temperature respect to the gas pressure at constant volume? The volume of the container is constant, doesn't change. We observe that when the gas is heated, the molecules move faster with the more velocity and gains more kinetic energy. This means that the number of colliding or the number of impacts becomes more often with the wall or internal wall of the container. This exerts a greater force on the walls, so the pressure increases. This graph shows the relation between the pressure and temperature. The pressure measured by Pascal is the unit for measuring pressure. The temperature is measured by Celsius in this scale. When we draw this graph, we observe that the graph represented by a straight line. This graph, when it is completed, we make intersection at this point. At this point, the temperature equals 0 Kelvin or negative 273 degrees Celsius. When we make extension for this line, with extension for this line, the intersected point is called 0 Celsius or negative 273 degrees Celsius. This point is the minimum temperature at which the pressure of the gas vanishes theoretically at constant volume. This graph displaying pressure against the temperature is drawn linear, not directed, does not pass through the original point. This is the experiment, due to the experiment, because this is value for pressure at 0 as the particle is in motion state. This relation is called Foyle's law. Foyle's law. Foyle's law studies the relation between the pressure and the temperature, the pressure, not the pressure and the volume, pressure and volume. But we study the pressure and temperature. It's called pressure's law. It's called pressure's law or Joule experiment. Joule's experiment or Joule's law. Joule's law studied the relation between the pressure and temperature, the pressure and temperature. We are going to study the relation between pressure and volume, pressure and temperature, volume and temperature. The relation between pressure and the temperature is called the pressure's law or Joule's law. The relation between pressure and volume is called Boyle's law. The relation between volume and temperature is called Charles' law. Number two, the change of gas pressure with the volume. The relation between volume and the gas pressure at constant temperature. This container contains number of molecules of gas. This is the molecules of gas, enclosed gas, rapid gas. If a force exerted on the surface of the piston, it moves down. And the volume of the gas, this is the volume in the first state. This is the volume in the second state. Vol 2 is less than Vol 1 due to the compressibility of the liquid, of the gas, and due to the wide intermolecular spaces, so gas can be compressed and the volume decreases by increasing the pressure. This force on this area is called pressure. When the volume of the gas is reduced, Vol 1 greater than Vol 2, Vol 2 less than Vol 1. Molecules in smaller spaces, the gas is denser. But all of them at constant mass. The number of molecules does not change. The mass of molecules does not change in this experiment. Colliding more often with the wall of the container. With the wall, meaning internal wall of the container. This is the internal wall of the container. The collision takes place between the internal wall of the container, not out of the container. So the pressure increases. The volume decreases. Pressure increases. This means that the relation between them is inversely. This is inversely relation. Directly represented by a straight line. But this relation is inversely. At this point, the pressure is large. But at this point, the volume is small. This means that the relation between them is inversely proportional. Pressure of a gas is inversely proportional to the volume. When the temperature of the gas is kept constant, this is called Boyle's law. Boyle's law studied the relation between gas molecules, or Boyle studied the relation between the pressure of the gas and the volume of the gas at constant temperature and the mass of the gas. For example, if a gas is trapped in a metallic cylinder like this is a metallic cylinder, in a piston, no heating means that the temperature is constant and the piston is released. This is the first state. This piston is released. The volume increases. From this precaution, this experiment must be slowly to prevent increase in the temperature. If it moves to left, this move to left, and stopping only when the pressure of inside equal the atmospheric pressure, means that this is the molecules make pressure, this is the external force make pressure, BA, atmospheric pressure, this is the pressure of the gas. When the upper side of the container stop, stops, the pressure difference equals 0 because the atmospheric pressure or external pressure equal internal pressure exerted by molecules of gas. And the density of gas is less. Why? The density is less. Since the volume equal mass over density, or density equal mass divided the volume. The volume vol 1, the volume vol 2, the volume of the gas increases, the volume increases. When the volume increases, the density decreases because the relation between them is inversely. This means that the density of gas is less. The density of gas is less. The rate of collision or impacts with the wall decreases. The number of collision decreases. The volume increases and the pressure decreases because the number of collision decreases. This means that the pressure decreases, but the volume increases. This is the example for Boyle's law to show the relation between gas pressure and volume at constant temperature and on all experiments, constant mass of gas. Third point, when the change of the gas volume change with the temperature. Relation between volume and temperature at constant pressure. At constant pressure. This relation is studied by Charles. When the gas is heated, the vibratory motion of molecules or velocity of molecules increases and molecules gains kinetic energy, move faster. This means that the intermolecular spacing between molecules increases and the piston moves up. This push, volume decreases. This volume increases by heating source of heat when the temperature increases. The velocity increases, the kinetic energy gained increases, the intermolecular spaces increases, and the volume increases. As a result, volume increases, but pressure remains constant. When we draw the relation between the volume and temperature, this line extended and this line extended to this point. The point of extension is called 0 Kelvin, like the last point, or negative 273 degrees Celsius. It is the point at which the volume of the gas vanishes theoretically at constant temperature. There is a value of volume at 0 Celsius. This point is called 0 Celsius. At 0 Celsius, there is a volume of gas molecules. This graph displaying volume against temperature in linear. This line is called linear, as the volume for the volume of the gas at 0, particles are in motion. Goodbye and good luck, my students.